Hello, and welcome to today's webinar on the modernization of the powertrain, the next era of progress in wind energy production. Thank you for joining us today. We're excited to talk about this with you. As global electricity demand continues to rise, wind farms are under increasing pressure to deliver more, but many are operating with aging turbines that struggle to meet modern standards for efficiency, reliability, and grid compliance. That's where powertrain modernization comes in. In this session, our experts will explore how upgrading key electrical components can extend your asset's lifecycle, boost energy output, and drive cost efficiency. All of this sets the stage for the next era of performance in wind energy. Today's agenda highlights the challenges wind farms face and the benefits of powertrain modernization can offer. Be sure to stay tuned after this discussion as we share insights and answer your questions on how modernization can reshape your operational future. So let's get started. Today, joining us for this discussion are Michelle Schwery, Business Line Manager for Renewable Power in the U.S., who brings over 20 years of experience in motors, drives, and power distribution. Also joining us is Jacem Jacimovic, Global Service Manager for Renewable Power at ABB. He has more than 15 years of experience in energy, robotics, and electrification. Michelle and Jacem, the stage is yours.
Hello, everyone. And we would like to start saying why we take care about the wind turbines and why it's now time to act. And let me start with on the next slide saying that energy and affordable energy has always been the linchpin in propelling economic development and human prosperity. And that's valid today. And what you see on this chart, that in the last 2 decades, the demand for electricity has doubled from 13,000 terawatt hours to 27,000 terawatt hours. And the 2 reasons are driving this huge demand. Number 1, the growth of population and the wish to improve the life standards that's demanding more and more electricity. On one example, the US population today contributes with 4% to the total number of humans on our planet. And the same population consumes 16% of the world electricity. So if the rest of the world would like to have the similar life standard like the United States have, we as a society need to quadruple the electricity production. That's the number 1 reason. And the second reason, we are at the beginning of the new era of introduction of artificial intelligence. We use it in daily life to ask questions, to generate images, to use for autonomous vehicles. But just to illustrate, there's a huge demand to run these devices. Just to generate an image using artificial intelligence tools is using as much as electricity as is stored in the brand new smartphone battery. So the electricity demand will increase even further than what is depicted on the graph here. And the next slide, we will elaborate how much we can do to meet this demand. So what you see here, that in the same period of time, the introduction of renewables energies like hydroelectric power, solar, hydrogen, and wind has increased faster than the demand of electricity. So today, the electricity produced by renewable sources of energy contributes with 30% of the total electricity production in the world. Just think about that. Every 3rd electron coming through our cables comes from the renewable electricity. And in the next slide, we will see that one of the fastest growing source of the new electricity is the wind. Today, wind electricity production contributes with about 10% of the electricity production. And only 1 decade, the production capacity has quadrupled. And what is very important, Wind and electricity is free resource provided by Mother Nature, and we can say that wind is like a gold, invisible and free resource, precious resource of electricity that we can use. And today, just to illustrate, this 23,000 terawatt of power is produced like equivalent 1,500 carbon coal power plants. So wind is replacing this and contributes a lot. And in the world that we are coming in, every single electron is important, and we need to take care about the new power plants, but also to take care about the aging wind turbines. 400,000 of the turbines are already installed, and why it's time and what is happening now, my colleague Michel Schwery will elaborate.
Thank you, Yachin. So if we go to the next slide, we can begin talking about the aging wind fleet. So approximately 2/3 of these turbines that are installed across the globe were delivered more than 10 years ago. With the design lifespan of a turbine being 20 years, owners and operators are reaching a critical stage in the turbine life cycle as that install base is aging. With funding options and frankly permitting options being limited, the question is being asked is how do we support those operations and meet energy production needs, all while extending the life of the existing install base beyond that initial life expectancy. So electricity consumption demand is going to continue to grow. I think we've covered that here a little bit earlier. And with that demand being driven by semiconductor, battery manufacturing, artificial intelligence, and electrification of transportation, the production of renewable energy must continue to operate reliably. On the next slide, we see that without proper maintenance, turbine performance is going to degrade over time, and that's going to result in reduced energy output and increased unplanned downtime. Modernizing systems enhances performance, enables compliance with an increasingly stringent grid code while boosting overall efficiency. As the turbines age and approach their end of life, the cost and lead time for replacement parts on those systems is going to rise significantly. It's been trending 10% more year over year. And that's just the beginning of the challenges that are faced by owners and operators. Grid codes changing every year, becoming much more strict. And with each change made to align to those grid codes, the performance requirements of the equipment installed raise that bar on efficiency and stability. Cybersecurity is also a universal concern, but specifically in energy production, a single breach can cause significant damage to a turbine and can lead to serious disruptions, putting the entire operation at risk. So it doesn't really matter where that farm is. The barriers for repower are similar across the globe, with turbines being 10 to 20 years old. Supply chain limitations on older technology increase the cost of maintaining older equipment and drive the need to repower to more current technology to keep those operations running. So on the as early as 2025, the European Union is set to decommission 22 gigawatts of wind capacity, with an additional 12 gigawatts slated for repowering. In the United States, with over 75,000 wind turbines in over 1,500 wind farms, this really marks a critical juncture for the long-term planning on the electrical powertrain. Operators are now faced with a really pressing question, which is how do we manage aging electrical infrastructure while maintaining operational continuity and meeting site-specific energy production targets? With global energy demand projected to rise 8 to 12% over 2025 levels in the next 5 years, the need for strategic action is clear. So where do we begin in defining the necessary steps to ensure equipment reliability and performance in this evolving landscape? On the next slide, we see that the electrical drivetrain is the link to the better energy potential. So through efficiency, reliability, scalability, grid compatibility, it really brings everything together. So it's at this junction of the life cycle of the converter and generator that brings modernization to that center stage of that operational longevity. Looking at the electrical drivetrain from blades to the generator, through the converter to the grid, really that's the lifeline of the system. In this example, the converter, that's the brain of the turbine, and the generator transforms the really powerful rotation of the blades into electrical energy that serves as the powerhouse that drives the flow of electricity into the system, making the generator the heart of the turbine. So on the next slide, it's really important to see that we keep the system operating healthy and reliably. So just like you do your own health check on your own heart and mind, you need to do the same with your converter and generator. As the O&M budgets are frequently consumed by needs for repairs on the gearboxes and blades, the generators and converters have often been overshadowed over the years. And now the electrical components and the converters that need to be overhauled, and the generators are being faced with repeated failures that are both costly and extremely inconvenient. Without proper maintenance, the downtime of these systems will continue to increase and that reliability will decrease, leaving operations at a standstill. The problem will continue to get worse as these systems get older. Electronic components in a converter face failure due to harsh environments that they exist in with dust and humidity. Their semiconductors have a life expectancy due to the stresses from continuous rapid thermal cycling. In a generator, the magnetic slot wedge faces constant forces from the main magnetic field, along with constant vibration and high temperature. This battle will continue to keep the systems online and producing in the busy seasons. The LCOE of onshore wind is the most competitive that it's been, lower than new coal and competitive with natural gas. By attending to the modernization needs, older wind farms can now see their best local cost of energy and reach their potential for less costly production. Yachim, I'd like to hand it back to you here for powertrain modernization.
Thank you very much, Michelle. And before entering into details here, just to say that ABB has been active not only in wind, but also in other conventional industries, and that started earlier than wind. And build up on the decades of experience there, we are now introducing the powertrain modernization into the wind energy. And again, from the learnings from other industry, we can simply state that powertrain modernization is awakening a new dawn of progress in wind park operations. On the next chart, we will show what happens over the lifetime for either power converter or for the generator. What you see on the vertical axis is the performance, and the horizontal axis are the years of operation. And the electrical components, with the best designs, after 10 years of operation without proper maintenance, the performances are deteriorating, reaching the end of the lifetime somewhere between 20 and 25 years. Following the preventive maintenance schedule that happens, one can keep the same level of performances up to the design time of 25 years. But what we saw in other industries, what we also illustrated later in the wind, with modernizing the electrical equipments like converter and generator in the age of 10 to 15 years, one can achieve two goals. Number one, increase the performances. And number two, double the lifetime of those components and to reach 35 to 40 years in operation. And with this, what we can say that, but we know that the economic progress of the wind farms does not happen. The economic progress of wind parks is made by working together between wind farm owners and component suppliers. And we are happy here to introduce ABB solutions to improve the performance in the wind parks. We'll start on the next slide, first with converter solutions, and then later on the generators. On the next slide, what we can say for the wind converters, we offer three possibilities. Number one, refurbishment. Number two, upgrades. And number three, replacement. Let me dive into details on the next slide. Workshop refurbishment, it is reassembling the most critical components, refurbish them, and put them back to the original state to ensure that the converter work properly. And then like refurbishment to the power modules, so semiconductor part, but also some other power electronic components that are aging. So we put them back to the original performances and minimize the turbine downtime, providing high robustness and ensuring spare parts availability over the design lifetime. That's about workshop refurbishment, and we do it locally close to your wind farm, thanks to the global network of ABB workshops. On the next slide, we introduce the new technology to double the lifetime of the converter. So this would be brand new power module with the semiconductors and power electronic boards, the latest design that ensure doubling the lifetime, increase the power rate by up to 5%, increase resistance to the grid disturbances that are now happening very frequently, and enhance the system efficiency. And that we can offer for the ABB ACS 800 fleet. So we are bringing new technology for that. That's about low voltage converters. And now if you move to the next slide, one more offering is that focusing on the most advanced control hardware and together with the software. So here we will replace control boards, control hardware with the edge devices for the data collection. And again, similar like in the previous case, increase the lifetime of the converter. In this case, since we are working also with a very advanced software, we could raise the power rating up to 10% and enabling the latest demands for the grid operators, like for the converter to have island mode option and grid forming capabilities, and enable the state art of the cyber security. This was about converter. Now, on the next slide, we introduce what we can do for the generator. But before that, just to say that in case when we do the repowering, what is also possible that some wind parks replace the nacelles, but without leaving the converter intact. To ensure that turbines will reach that demanded lifetime, we could bring the new converter either inside the tower or we could have an outdoor solution. Next slide, please. Now, speaking about wind generators. There we will have two types of solutions. Number one, workshop refurbishment, and number two, replacement and ABB generator on stock. On the next slide, what we see is that ABB workshop refurbishment for the generator brings the new stator that increase annual energy production up to 5%, increase reliability, and in the last 10 years, all the generators that ABB upgraded in the workshop reported zero magnetic wedge failures. This was in past one of the most common failure modes up to 2014. And now, whenever we do the upgrades, we have zero reported magnet slot wedges problem. And in the next slide, what we have also is possibility to have generators on the stock to ensure, number one, fast delivery, and number two, tower ready, with improved reliability and increased equipment lifetime. On the few cases to illustrate for both converters and generator, I give the microphone to my colleague Michelle, who will guide you through that.
So on the next slide, we wanted to share with you some real-life examples of modernization in the field that show the benefits of the different options available that have been installed across the globe. So the first of the example is on the control hardware and software on the medium voltage converter that is used in offshore wind. These systems are 10 years old and were installed with the originally designed technology for that system. So through advanced control methodology deployed in that PCS 6000, we've seen improved converter efficiency by up to 5%. This is through a newer central processing unit in today's controller hardware. This newer technology is 5 times faster what was originally designed for the system when it was designed 20 years ago. This allows the system to respond faster and more efficiently with inertia response, which keeps the system running and producing electricity through grid disturbances. By bringing together the newer CPU and the newer software, it allows the system to provide the voltage even when the main grid voltage is absent. So this keeps production stable and keeps the turbine in sync with the power grid. New software and new hardware allow the system to avoid long lead time for replacement parts that it faced in the past. And the ROI on this upgrade in the system was realized within 1 year. On the next slide, we'll talk about power module and cabinet modernization. So the ACS 800 system that has been in onshore wind with ABB has really truly been a workhorse over the last 20 years. Since the release of that system, the next generation of workhorse has been designed and released to the market. By upgrading power modules from the older 800 system to the newer 880 solution and replacing all older cabinet components, the lifespan of the converter is now doubled and with better system reliability and production. So depending on that system being upgraded, this also lowers the loading factor on the system and reduces the thermal stress on the semiconductors. With this job we're sharing here, it's also met the latest grid code requirements for both high and low voltage ride-through. So through reduced downtime and better system efficiency, it's easier to see why the return on investment of this system was also realized quickly. New power modules deliver higher system efficiency with the latest technology in IGBTs, and that is with the latest module design. The energy output is more reliable because the system continues to operate. The converter is more resilient to higher coolant temperatures. On the next slide, we're going to talk more about modernization of the generators that Yachim was talking about. So we spoke about the generators, gearboxes, and blades being top of the list in failures of a wind turbine. With the generators, the magnetic slot wedge is a common failure point, with some sources stating that it can be more than 12% of the failures in generators with that design. In the case of the upgraded stator, customers can remove that failure point in the stator. By upgrading with these stators, customers have reported, like Yachim said, 0 failures since 2014. That's 0. So with a new stator, customers are now producing more effectively and reducing their failures by that 12%. That doubled the lifetime of the unit, or potentially longer. And with the Class H insulation, the generators are designed to withstand repetitive pulse voltage from the converter. Eliminating that magnetic wedge avoids the long downtime needed to swap out the generator in the field and keep the system producing steadily and reliably for the customer. On the next slide, I want to reiterate the fact that drivetrain failures in wind turbines contribute to over 70% of the annual OPEX and downtime costs. So implementing comprehensive modernization services can significantly enhance the reliability and performance of both the electrical and mechanical drivetrain. This shift can help overcome historic reliability challenges that have been faced with these assets. Following recommended maintenance schedules can reduce that OPEX by up to 10% and boost energy production by as much as 5% beyond those projections. And extending the life of the electrical components by 10 years or more can be achieved through planning and enable the turbines to operate more economically, potentially, again, doubling their service life from 20 to 40 years. Modernized converters and generators are going to bring us to the next era of wind energy production. It's time to begin addressing life extension, increased capability, cybersecurity, grid compatibility, increased productivity, and the need for repower solutions for the fleet. These solutions are here today for converters and generators. Today they're here. And owning your maintenance and modernization program for the systems that you manage, it's going to put you back in the driver's seat by making informed decisions on your fleet. Not only is that good for your site, but it's good for the community that these turbines support as well. Now back to you, Jody.
Excellent. Well, thank you, Michelle and Yachum, for those great insights. We're now going to open the floor to questions. So if you haven't already, feel free to type questions into the Q&A box, and we'll address as many as we can. So let me look at the box and see. Okay. So, Michelle, I'm going to ask you this question. How can modernization extend the lifetime?
Yeah, so there's a lot of things that contribute to the shortening of the lifetime of the equipment. That is parts availability, supply chain, and the environment that the systems exist in. So by modernizing your systems, what you're doing is you're taking what's old and you're making it new again. In the last 10 years, there's been a lot of technological advances on this equipment. It's also much more readily used in the market and makes it much more available to provide to the customer. So more reliability, better availability, and really better efficient operation leads to that lifetime extension.
Okay, and we have a question. Has ABB done any work with electrical and current signature analysis monitoring systems on wind turbine generators, specifically looking for common generator failure modes early?
Yeah, I can take this. Thanks, Jody, for the question. So for this type of activity, ABB has partnered with another company called Windesco, where we put the joint forces with the ABB decades of knowledge on designing the generators and Windesco data science capabilities. So we developed together a device that collects the most important data in the current, electric current, vibration, magnetic flux, and voltage from the generator, and use this data to detect loose magnetic wedges, rotor bar damages, and others. So once more, it's a common development and common product from ABB and Windesco.
Thank you, Yachum. So we got some good questions coming in. This one is a good one for this topic. How does the return on investment for modernization compare with that of building a new turbine?
So I will take this one. If you take a look at modernization, and by modernizing some of the components within the turbine, you can find that you can achieve better output without having to spend the money to replace the entire turbine. So it all really kind of depends on the site and the budget and what's available to them. But the ROI, your downtime is shorter. If you're modernizing your converter or your generator, with the latest technology, you're going to be able to produce longer, and it's going to eliminate the need potentially of having to replace your turbine. So yeah, I mean, I think if you're looking at that ROI, it's fairly quick with the modernization, depending on what your long-term plans are for the farm. It really just has to tie into what are your plans and what does the future look like for your farm.
Okay. And so we did have a question that said, just to make sure I understand correctly, the power electronics are the most vulnerable component in the lifetime assessment.
I can take this one.
Would you agree with? Go ahead.
Well, all the products have certain lifetime. If you speak about consumer electronics today, like smartphones, computers, the lifetime, people change them within 3 to 4 years. What we have here we have industrial electronics, power electronics, that semiconductor chips, they could last long, 20, 30 years. But there is electronic around semiconductor chips that has, for instance, electrolytic capacitors. And those components have a lifetime, 10 to 12 years, and after that they start failing. And that we have, it's not specific for wind, that's what we've seen in all other industries, the same pattern. So yes, there is, we need to take care about electronic components and to ensure to meet the 40 years of the turbine lifetime to modernize those components.
Okay, so for the inverter, do all inverters inside the converter need to be replaced to upgrade to ACS 880 from an ACS 800?
Yes. You would want to upgrade the entire system to an ACS 880 platform from the 800 platform, yes.
Okay. Can modernization strategies be standardized, or are they custom for each wind farm or turbine type?
So the modernization is standardized up to 80% of the package. So that's standardized, and we can do 20% fine tuning to be site specific.
Okay. Does ABB partner with other companies to provide refurbishing of other parts of the turbine, such as blade repair, modification, or replacement?
We are focused on the converters and generators, so we do not do blade repair.
And I think the question was, do we partner with anyone to do that?
Yeah, we do not do that either. It's with a blade repair, it's much more cost effective for the farm to go work with somebody who has a focus on blades. So with our focus being an ABB in general, we're about energy efficiency. We're going to focus on the electrical components in the system. So blades we would want to leave to the experts, and no need to put us in the middle.
Okay. I heard you mention high and low voltage ride through. Can modernization of components help meet the new PRC 029?
Yeah, we have done this in past where we bring the new components inside and enable fulfilling the latest grid requirements for the both high voltage and low voltage ride-throughs.
Okay. What innovative solutions has ABB introduced to the wind energy market that enhance performance, efficiency, reliability, the things we're all looking to achieve, particularly with cost effectiveness in mind?
Yeah, I could take that one. So just one example among many is several years ago, we introduced modernization of the power converters for offshore applications that increase from the converter point of view, just through the software, 10% higher output of the converter, that converter guarantee. Then we brought the highest efficiency thanks to the, again, new control software that we developed. And we introduced the edge devices that could collect the data in a real time for two reasons. Number one, in case of a problem, that we can have below millisecond data to do the troubleshooting immediately. And number two, that we can take the data and then monitor the turbine performances one by one, and customer then could optimize overall energy output from the whole wind park. So both control hardware, control software, and power modules.
I think I'd also just like, if you don't mind, to comment on that. When we talk about also the cost effectiveness of the upgrade, when you take a look at what your repair costs are, and calculating how that affects you long term, and put the comparison of that upgrade side by side, you'll very much be surprised at how an 880 upgrade solution is going to be much less for you in the long run than continuing to repair for the next 10 years. So I think that it's really important when I talked earlier about owning the maintenance and really owning what your plan is for that electrical equipment. It's take some time and do that deep dive on that cost effectiveness, and I think you'll be surprised at the outcome and what that cost effectiveness is for your site.
Thank you for that addition, Michelle. We have a question on, is it possible to service the generator, sorry about that, it jumps, on site, or does it have to be taken down?
I can jump in here. So it depends on what the issue is. I think that if you're doing the maintenance and understanding the condition of the generator, the goal is to not have to take that down. So, I would encourage, working with your own technicians or with your partner technicians to see, really what is the issue that's happening and what is causing the issues on the generator, because you always want to avoid having to take that out. But you will at some point get to a point where you have to bring that system out to repair it, depending on what that issue is. So, I think that's key. Always try to work with your technicians first, those trusted technicians that know your site better than anyone else, and do what you can to avoid the failures that'll require you to take the system out.
Okay, there's a question on, how does ABB support the integration of wind power into existing grids, particularly in regions with limited infrastructure?
I can take that one. So what we developed the wind power converters that has a controller part and control software. And what we promise that our software fulfills the latest grid codes. What's our previous question about low voltage and high voltage write-throughs, that we could provide this really long period of time in terms of power electronics, that we could be stable on the grid. And that's how we ensure. And also, second, like we have for the offshore application, possibility of the island mode, where the infrastructure is not as in the onshore, that we could ensure stability of the power production.
Okay. We also have a comment on working with or talking with OEMs about lifetime extension of tower and EOR on foundation lifetime extensions. I don't know if y'all want to comment on that. It's not really a question, it's just a comment that we've received.
I could comment on that. We have been working with both turbine OEMs and wind power corners. We have success cases in both. In one current example, where we recently delivered together with the turbine OEM full control upgrade to ensure that it's a good stability between power controller and turbine PLC. So we are open with both, working with turbine OEMs and wind power corners.
Okay, thank you. And I don't see any other new questions entering the chat. We did have someone that asked how they could learn more about the ACS 880 upgrade. And so in just a minute, we'll put a slide on the screen that has a place where you can let us know if you have additional topics that you need information on. There you go. There's a QR code where you can let us know if you need specific information, and we'll make sure that we get you the right resources to learn more about that. So if you'll just take a moment to scan that code and let us know if there's anything you want to discuss. Michelle and Yanshan, thank you again for these great insights today and the great discussion around such an important topic in renewable energy. And for all those joining us online, thank you for your time this morning and spending this morning with us to learn this. We've enjoyed having you, and we hope you all have a great day.
Thank you very much, everyone.
Thank you very much.